Okay, or maybe you could do this. Show me your GitHub profile. If I like it, you get a book.
रोम रोम भाइयों
Hello. Welcome everyone. Welcome to the quiz. How many of you have been to a pub quiz before? Raise your hand. Give me a who if this is like your first pub quiz ever. Oh wow, nice. So I'll give you a very quick. I'll just tell you how pub quizzes work. So we are going, especially this one, we are going to have 4 rounds, and each round will have 5 questions. You should have already received an answer sheet and a pen. All of you received it? Okay, cool. And also, one team, like these are teams of 2, unless you want to compete individually. So whoever wins also, like there are some really good programming books here, and whoever wins the prize. The team that comes first gets the first dibs on whichever book they want to choose, right? And there are 3 prizes. So 6 people have their pick. Okay.
Can you guys hear us?
So we once again, so that everybody gets the format, we are going to have 4 rounds. Each round will have 5 questions. You write the answer in the paper. 1 team, 1 sheet, unless you want to compete individually, and you'll also, each question will be shown for a minute. It won't be shown again. So you want to make sure you get the question and your answer within that minute. And one catch is that the rapid fire round, you'll only get 30 seconds because it's rapid fire, right? Shall we begin? Everyone ready? Super. So the first round is called What is Sex? Yeah. Sorry. Wow. Wow. Dude, you already won the first prize. So the first round is called What is Sex? And I'll show you an image and a short description of the image, and I want you to identify what that is. Okay, let's have the first question, please. So this image represents X, and X is absolutely important to keep the order of events in a distributed system. And I want you to identify what is X. Again, this image represents X, and X is crucial to keep the order of events in a distributed system. And what is X?
So don't get overwhelmed if you don't understand this. This is one of the difficult questions to begin with. If you don't know distributed computing, it's fine. But yeah, it'll get easier with time. How many of you have an idea of this? A few people. Okay, cool. So 40 more seconds, then we'll proceed. Ek banda likh lo. You guys are a team, right? Yeah.
Again, if you're a team, 1 answer sheet is enough, unless you want to compete individually. 2 people, 1 team, 1 answer sheet. The hint is the image itself. See what is there. You have a clock, and on top of the clock you have a symbol. That's the hint. If I break it down any further, I'm going to give you the answer myself. Okay, once again, this image represents X, and X is crucial to keep the order of events in a distributed system. In a distributed system, when you have multiple nodes, events can happen out of order, and This allows you to maintain the order. Next question, please. Okay, so I will, anyway, I'll tell you what is in the image. There is a table, and there is Vladimir Putin on one side, and then you have, I think, Emmanuel Macron on the other. As you can see, it's a very large table, right? And there are people on two ends. That's what the image is. And now to the question. X is a distributed storage system developed by Google to provide high availability and scalability for large-scale applications. What is X? Again, on the image, if you're not able to see, it's a very, very large table. Yeah, I mean, I can't break it down any further. I gave enough hints in describing the image already. Okay, 10 more seconds on this question, or we can go to the next one.
Go to the next one, guys. Yeah. All right. Cool. Next question.
Okay, I'll describe what you see on the image. So you see the image has like 3 processes, and in between these processes you see that there is a channel, and and these processes are communicating with each other via the channel. And as you can see, there is one process executes, and then it does something, either reads from a channel or writes to a channel, and then it gets blocked. It also does get synchronized. So now the question, the image shows 3 processes communicating with each other via a channel. Whatever, this image represents a very, very concrete formal model of X. I want you to identify what is X. So once again, the image depicts a concrete formal model, and I want you to identify what is X. It's a very, very well-known concurrency model in Golang. So to go back to the question, you have 3 processes communicating with each other via a channel. They can either execute, each process can either execute, get blocked, or synchronize using the channel. And this concrete formal model X is a very, very well-known concurrency model in Golang. And I want you to find what that is. Did you spend enough time on the question? Yeah. Move to the next one. Okay. Are you able to? It's a very, very popular algorithm, virtually running on billions of machines. Those machines are named after a famous Indonesian island. And the algorithm is also notorious for stopping the world randomly. And I want you to find what that algorithm is. Yeah, I want the exact answer. Yeah, I want the exact answer. I have given you enough clues already. The question probably has some 4 or 5 clues. Yeah, shall we go to? All good. Shall we go to the next one? Okay. So this is a very commonly used pattern in both merge sort and quick sort. I want you to identify what that pattern is. We should have probably put this in rapid fire.
Yeah. I mean,
it's okay. So you see the image, and the image is like a very commonly used pattern in both quick sort and merge sort. Identify what that is.
Can we proceed on this one, guys? This one easy? Yes. Was this one easy? Yes. This is the first one I put, so that's all right. Sorry. So new section, guys. Find the connection. The goal is simple. You will be given some sort of images. You need to figure out what the final thing it's pointing to. So it's a little ambiguous. Let me start with the first one. There is a graph of, let me give this up, strongly connected components. There is a naked man over there in the jungle, and there's a car over here. Now you have to find what the image represents. Find the connection. If you have done DSA, should be straightforwardish. It's an algorithm to find strongly connected components. Name of the algorithm. But there are hints here, so.
Also the right spelling.
Yeah. Spellings are key. I don't think this is guessable, guys. Shall we proceed? You good to go? All right. Next one. This is for the Web3 folks in the house. There's Bitcoin on the left. Sorry, there's a Mixie on the left and Bitcoin on the right. That's all the hint you'll get. I think that's fairly obvious if you're a crypto degen. All right, there you go. I'll give a hint. You can replace the thing on the right with anything. Doesn't have to be Bitcoin only. Can be Ethereum. Can be a different blockchain. Mixer remains constant. All right, guys. I think we'll proceed.
Okay, so there are 4 images on the screen. So on the first one is Morris worm, and the other one is SQL Slammer, and the other one is Heartbleed, and the other one is iMessage exploit, iMessage zero-click exploit, right? So these 4 are exploits. That's not the connection. I want you to find what underlies this vulnerability, what is common to these 4 vulnerabilities. Again, Morris worm, SQL Slammer, and much more recent ones, Heartbleed and iMessage zero-click exploit. So Morris worm was the first ever vulnerability way back in. It's almost as old as the internet. SQL Slammer is like it's almost as old as the .com bubble, and Heartbleed is much more recent. And this zero-click exploit famously cost somebody's life and also somebody's marriage. And there is also a clue. The clue is this code that you see right here. The next one. Yeah.
Boy, that's like.
Oh, it's not.
So just to give a hint, there's like a forest over here with a bunch of trees, and then there's a bunch of trees here as well and a bike. But there's something else also. So just look at the image. Unless you look at the image, you won't know. That's already too many hints. There's also a clue on this one, even though it's probably more difficult. Again, to show the image. The answer is right here, guys. All right, everyone knows? Cool. Yeah, that's a simple one. Can we proceed? All right, good to go. All right. What's common in the 2 terms you see here? How many of you don't know IPFS? Okay, everyone. Few people don't. Internet, what is it called?
Interplanetary
file system. Interplanetary file system. And the other thing on the right is BitTorrent. Think what's common. Yeah.
No, it's so specific.
It's an algorithm though. So here is a clue.
You need to find the common data structure. The clue is there is a common data structure that is used in both IPFS and in BitTorrent, and I want you to find the common data structure. Shall we move to the next question? So on the image, you'll see 2 logos. One is IPFS, the other is BitTorrent, and both are very popular peer-to-peer networks. And I want you to find the common data structure between these 2 peer-to-peer networks. A clue is that it's a data structure that I want you to find. Shall we go to the next one? Yeah, so now this is a rapid fire round. We'll flip through the questions very fast, like not more than 30 seconds. So I won't show the question again. Let's go. Identify the design pattern. What do you see here? You see an image. I want you to identify the design pattern. Okay, you see the image, and this is a very popular design pattern, and I want you to identify that. How many of you find this question easy? Okay, next, yeah. So which law states that the number of transistors in an integrated circuit doubles about every 2 years? There is a specific law that says that the number of transistors in an IC doubles every 2 years. There is no stream to wait for, and I'm going to flip over to the next question very, very soon. So there is a law that says that integrated number of transistors in an IC doubles every 2 years, and I want you to find that. Okay, next question. So there are two algorithms that you see here. I want you to identify the algorithms, and better you will get bonus marks if you tell me the class of those algorithms. Identify the class of those algorithms and what they are used for. So these are the two images. What is the street name for Brewer's theorem? So there is a very, very popular academic theorem called Brewer's theorem, and it has a street name, and I want you to identify that street. What is that? I want you to tell me the street name. It's a rapid fire. Street name, I mean, if you are a distributor, this is like very, very central to distributor systems.
System design, first theorem.
Yeah.
Come on, any system design concept, theorem you know.
What is the street name for Brewer's theorem? Okay, next question. I think we spend more. What is C in CRDT? And do CRDTs commute or converge or both? There are two questions here. I want you to answer both. What is C in CRDT? And do CRDTs commute or converge or both? Yeah, I know this is a hard one. Unfortunately, I don't have a clue for you. Again, what is C in CRDT? Do CRDTs commute or converge? And to give you a hint, I could tell you what CRDT is useful for: strong guarantees on eventual consistency. And so I want you to identify what is C in CRDT, and do CRDTs commute or converge or both? Okay, next question.
Alright guys, how's the quiz going? How are you guys feeling? Disappointed? I'm feeling pretty disappointed. I felt the same when I targeted a lot of these problems. Last section, thankfully, has been made by me. So, should be easy, but I don't know, we'll see. It's called How Do You Find X? So, it'll... Oh, how do you fix X? Yeah. Okay. So, there will be a story, so it'll probably take longer than a minute. You have to read through that story and figure out how do you fix the thing that's represented there. A lot of this should be fairly full stack, so if you know full stack development, should be easy enough. Let me just iterate, it's really small, so what she said. Scaling a front end. X is a niche digital art store built by a novice engineer in React. X is a website built in React by a novice engineer. Their website grew really well. However, their page loads are turning out to be very slow and their bandwidth costs are really high. How would you fix these problems? What would you use to scale the deployment of a front end for a website that grew easily? I will repeat. If you have a front end and you want to scale it to 1 million users, 1 billion users visiting it, how do you do it? आ रहा है ना समझ आप चलो मज़ा आएगा. All right. Can we proceed, guys? Good to go? Like second. Next question. Securing a backend. Laveshwar, notice the word, Laveshwar, built a lead code like system, and he's a novice engineer. He's suddenly seeing a lot of dummy files on his EC2 machine. He built a lead code type system, and he's seeing a lot of random files on his machine. He also notices that a lot of his data is getting leaked, his database credentials are leaked. What vulnerability does he have if he's trying to build a system like lead code and he's seeing a lot of these problems in his backend? He's seeing that the backend is going down, his data is leaked, his database credentials are out, and he's seeing random files on his system that people are able to put and execute there. What vulnerability does he have? This was the only difficult one here. Everything else should be simpler. Shall we proceed? Good to go? I will take that as a yes. X is a sneaker drop website, and they do rare sneaker drops from time to time. But they're noticing that rare sneakers get taken up by the same user every time. For some reason, anytime they do a rare sneaker drop, a single user is able to take all of them. They also notice that the website becomes really slow during the drop phase. How can they prevent a single user from hogging up all the cheap but rare sneakers? Whenever a drop is happening, whenever an event is happening, their systems are going down and a single user is able to take everything. There are two answers here. Either is fine. Alright, to repeat a question, how can they secure their backend that receives a lot of traffic from a single user during a drop? What can they use? What is this attack called? Anything is fine. How can they secure their backend? Good to go, guys. Another question on scaling the backend. Raman is a new engineer who wants to start a website, but he is unable to anticipate the load of his website initially. It will mostly be used by a few people. He also doesn't have the money to start EC2 machines and give $20 away. What technology can he use to quickly deploy a backend that scales and he doesn't have to pay a lot for it initially? How can he not get a server yet deploy his application somewhere, considering he cannot anticipate the load and doesn't want to own auto scaling? To repeat the question, he's anticipating he doesn't know what the load will be. What can he use to not pay a lot of money and scale? Last questions, guys. This one's a little difficult. Nimit is a fresher and he built a system where multiple backends are talking to each other on different clouds, across clouds. Suddenly there was a spike in the number of requests shared between these systems and he noticed the bandwidth bill is huge. What technology can he use to decrease his bandwidth bills when two backends are communicating across different cloud providers? I will repeat. Two backends are communicating. How can you make their communication faster, easier, and consume less bandwidth? How can you decrease the amount of data that's being shared between backends? Hopefully that was insightful. I don't know. Let's give a huge round of applause to yourselves. We'll take a break, a small one, then we'll go through the solutions. And as we do, you can just self-check and let us know your points yourself. Let's take a break of 10 minutes and then get back.
How do you guys feel about the quiz?
Was it difficult? Or was it
too difficult, like answerable, enjoyable? Like,
How many-
Did you guys have fun first of all?
That's the question. All right.
All of you had fun? Okay, that's great.
Second question is, was it easy? No. Was it difficult? Yeah. Was it very difficult? Yes. No. All right.
Right, guys, we're going on to the solutions. Please self-check and just...
Yeah, otherwise if you want to be extra sure, just swap it with, we are going to do something we did in 5th standard, just swap it with the next table. Yeah. Yeah, feel free to swap it with the next team. Make sure you write your team's name before you swap. Write the name of your team before you swap. Okay, make sure all of you written your team name, right? Make sure you write it before you swap. Okay, so the first question in what is X? This image represents X, and X is absolutely important to keep the order of events in a distributed system. And what is X? Does anyone know the answer? Feeling quite confident about your answer? You want to raise your hand and give it? Anyone wants? No, I mean, I'm going to reveal the answer anyway. So, yeah, Anushk. Yes, it's vector clock. Let's go to the next image. So vector clocks are absolute. You cannot order events based on timestamp in a distributed system because clocks drift. And in order to get around that, you have vector clocks and they give you like guarantees on order of the events. Next question. Okay, the image itself is fairly self-explanatory. X is a distributed storage system developed by Google, and that it provides high availability and scalability for a large-scale application. And what is X? It's a big fucking ass table right here. So What is X? Does anybody want to volunteer? Who knows the answer? Who is feeling confident about it? Yeah, just say, if you're feeling confident about the answer, just shout it out. What's the answer? Yeah, go for it. If you know, yeah, it's big table. Yeah. Okay. So, okay, how many of you think you got the answer for this? These are three processes that are communicating with each other via channels, and it's a it's a formal concurrency model, popular, also used in Golang. It's like the fundamental concurrency model in Golang, and the question was to identify that. How many of you are feeling confident about your answer? How many of you think you got the answer? It's okay, even if you don't have it, it's okay, volunteer with an answer. Oh, no. 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 Those are not formal models. I'm looking for a formal mathematical model of concurrency. Anybody, any of the new audience who just joined want to volunteer an answer? Okay, nobody has the answer? Drum rolls, the answer is communicating sequential processes. So these are, and Go's concurrency model, which is built on channels, is built on a very formal model of concurrency called communicating sequential processes, otherwise known as CSP. Okay, so this is a very popular algorithm running on 1 billion of machines virtually, named after a famous Indonesian island. And this algorithm is notorious for stopping the world randomly. So what is that algorithm? This is fairly easy. If you just look at the image, it's fairly easy. Okay, garbage collector is right. But I want you to find what the answer, the question was to, the question was to give the specific name of the algorithm. Because, I mean, if you look at the garbage here, he is collecting garbage. So it was a dead giveaway. If you got garbage collector, you still get half a point. But did anyone get the correct algorithm? Java virtual machine. No, that's not the question. I mean, the question was to identify. That was a clue for you. So concurrent mark and sweep garbage collection is notorious for stopping the world. Stop the world scenario is like a very common scenario that you run into with any deployment of JVM machines. So whenever you put stuff onto the heap, these are reference counted, and you want the garbage collector to, you have this running on a separate thread, you want to mark it and sweep it as you go. And when it still does it does it concurrently. That's why concurrent mark and sweep. Okay, it's very self-explanatory. How many of you think you got the answer? Okay, I should have just asked like this half of the table first and then this half. Okay, nobody got the joke. Yeah.
Alright guys, ये तो सिंपल था. क्या आंसर है? Great, ये मैंने डाला था. पता भी लग रहा है. Next question. Just press the arrow key, it'll work. All right, the answer was divide and conquer. Straightforward, I would assume. Next question. Find the connection. Next one. ये निकला किसी का? Strongly connected components. Striver apparently has a video on this. That's why I put it here. I assumed someone might have seen it. This is not the popular one to find strongly connected components. Hints were here. This is the Tarzan car. This is Tarzan. The algorithm is, anyone knows? It's Tarzan's, but there's a J instead of a Z. So if you had the right one, then feel free to give yourself a point. So Tarzan's with a J was the right answer. It's Tarzan's algorithm. Next slide.
That's the answer.
If you wrote this, then you're good. If you wrote a Z,
we'll see.
We'll see. Probably a 0 for now. Next one. Anyone got this? Fairly straightforward for Web3 people. Crypto mixers. That's the right answer. It lets you anonymize payments. If you wrote, there was a specific answer required here, but even if you wrote crypto mixing services, that's fine. CoJoin was is this CoinJoin? Is that one on Bitcoin? That's a popular one on Bitcoin. But if you wrote mixers, you're good. Alrighty. This one was a common attack that happened amongst a few of these popular attacks. Next slide. Sorry. Null pointer is not correct. And a lot of people wrote null pointers, but the answer was memory leaks, I think. Anyone got it? No one got it? Oh, you got it? Nice. 0.5? 1. 1 point. Alright, next one. Did everyone get this? Who did not get this? You got it? Who didn't get it? Everyone got it? I doubt that. The answer was red black trees. If you saw the image, hopefully it was straightforward. Yeah. Next one. How many people who wrote P2P here or something similar, should they get half a point or no? No?
Because I was to
Find the data structure. Okay. How many of you were able to find this one? Not exactly. Talking about what? Okay. Next one. The answer was distributed hash tables.
either distribute a hash table or currently if you have it, you get a point.
All right.
Okay, that's expired.
You want to do this?
Yeah, sure. Okay, I think this is a fairly easy one. Which law states that the number of transistors, blah blah blah, doubles every year? Moore's law. Yes. You get a point if you got Moore's law. Yeah, first one I think we skipped ahead. Can we go to the? What is the street name for Brewer's theorem? How many of you got this? Yeah, I think this has.
Oh, you get the idea, yeah. I think the question might be different. So Moore's law.
Yeah, you want to go to that waterfall question? Yeah. Yeah. So this is the first one that was. How many of you did not get this?
Yeah.
I mean, so waterfall model. Okay, can we? What was the next question?
Let's just go and random.
Yeah. I think the next one was the Moore's law. Okay, what's the street name for Brewer's theorem? Yeah. If you got cap, that's right. It's like that's Eric Brewer right there. So what is C in CRDT and do CRDTs? What did any of you get this right? You also actually get a bonus. Like I'll give a bonus point. It's a harder one. So if you get it, you get a bonus point. C is conflict free. You want the data. You want the underlying thing itself to be conflict free so that they are strongly eventually consistent. And the other C's are like they can both converge and commute depending on the operations that you choose. Okay, how many of you got this? I think this is fairly self-explanatory. Yeah. How many of you at least got the algorithm? That is a bucket. There's a bucket right there and it leaks. Yeah, that is right. And it's a congestion control or a rate limiting algorithm. How do you?
Alrighty, last section. I'm guessing a lot of good answers here, or like a lot of people got this right. The first question was, how do you scale a front end? Anyone want to take a guess on it? CDNs is right. If someone wrote something close, that's fine as well, but content delivery networks. There you go. Next one. Securing the backend. Maybe not really. 0.5 if you want to give yourself. All right, securing the backend. This was if you're building a lead code like system, what is the common vulnerability you might face? The answer was remote code execution. If you wrote something similar in that direction, should be fine. Next one. Scaling the backend. This was website becomes really slow during the drop phase. There's some sort of an attack that happens. How do you protect yourself? Yeah. Rate limiting is a good answer here. DDoS protection works as well. So yeah, that's. So what was that? That's 0.5. If you wrote limiting, you're fine. Yeah, that's fine. 1 point. आ सकता है. That's what rate limiting is. Mota mota. So yeah, feel free to give yourself a point. Yeah. Next one. Scaling the backend again. What was this? Oh. Do people get it? Serverless Lambda. If you wrote anything in that direction, works. All right. Great. If Lambda is a valid answer, then Cloudflare Workers is a valid answer. Next one. Making backend stock. This was a little tricky. The official answer here was protobuffs. Protobuffs, protocol buffers. But if you wrote gRPC, it's in the same direction, so feel free to give yourself a point. That's pretty much it, guys. That's the solutions for today's quiz. Thank you everyone for coming. Feel free to stick around. We'll be watching the match after this. But yeah, thanks everyone, and yeah, we'll be here.
Okay, now, who wants to volunteer their points? Who got the most? Is anyone here got 10? Like about 10? Anyone about 10? Raise your hand, raise. Okay, one team about 10. Okay, how many of you got above 5? Above 5. Oh, okay. Yeah, we'll wait for a few minutes. How many questions did you get, Irfan? Okay, 11 and a half. Anybody else over 5? Oh, 13.5. Okay, we have a 13.5. 13.5. Wow, nice. 13.5, 11.5 and 11. 12. Okay, 13.5, 12 and 11.5. Anybody in that between 5 and okay, 8.5. Nice. 5.5. Nice. Right, it's fun, right? Like, I mean, despite everything, the points and all of that, all of you had fun, right? Yeah, that too. And obviously the beer. So everybody had a great time, and yeah, with 13.5, 13 or 13.5? With 13.5, we have Ved and Preet as the first prize winners, and you get your first pick of the book. There are like 9 books. 9. There are more also. Like each of you get to pick whichever book of your choice. Yeah, so each team member get a book. So like each team member gets a book. Like, feel free. Okay, take your pick. I think we'll probably need to put like a time limit. Like, you have 30 more seconds to make a pick. Okay, awesome, great pick.
So what did you pick, man? Rust, Atomic, Commons and Laws.
I mean, both of you can't share a book, right? So. Okay. Sorry. Sargam. Yeah.
So the third prize is by 2 people very close to me, Sargam and Sujit. Huge round of applause. Nice.